In this question, we need to reconstruct a binary search tree with pre-order traversal. The given array is a pre-order traversal to a binary search tree. Pre-order traversal means we traverse a binary search tree, following the route that start from root, and is from it, then it's a left subtree, and then it's a right subtree. So according to this rule, it means the 5 must be the whole binary search tree's root, and because it's a binary search tree, we know that from any node from this binary search tree, all the value of its left subtrees are smaller than this node root value, and it's all the value from its right subtrees are bigger than this node value. So we know, based on this, for example, this the 5 is the root of binary search tree, and because 3, 1, 4 are smaller than 5, so it means 3, 1, 4 are from its left subtree. Left 8, 11 is bigger than 5, so it means 8, 11 are from its right subtree. Then we can we go into this subtree. Because it's pre-order traversal, 3 is this subtree's root, and 1 is smaller than 3, so 1 is 3's left subtree, and 4 is 3 right node. And this subtree 8 is root of this subtree, and 11 is right node. The node 8 doesn't have a left node. We use recursive method to build this binary search tree. Let's finish the code. Because we want to use the helper function to rebuild this binary search tree, so only here just the return help function create, and we need to pass the left and right side for the current node. We need to pass the left side, left and right, for to build its subtrees. For the root, the left side is 0, and the right side is from to the end of the array. So this is a helper function. Left index and right index. First, we need to discuss the corner case. If left bigger than right, it means there's already out of bound. So we return no for the root. Or if let new tree node first, the current root for the subtrees. The root is the left side left index of the array, the root value, and if left equals to right, it means only one value left in the array in this area. So it's not necessary to build subtrees based on this root. Only one node here. So we just return root. And then we build left subtrees. We need to pass left and right index. So we need to find out where is the left the smaller the range that smaller than root value, and the range that bigger than root value. So we need to find out the range. We can iterate this array then to find out which one the first one bigger than root value. We also can use binary search, which is more efficient to find out the first value, the first larger, the first value which is larger than root value. So this is a function that first find first larger than target. We pass the parameter because we want to traverse this array and the target, and the range we want to search, left and right. Just also corner case. If left bigger than right, it means out of bound. Just return -1. We didn't find out the index that bigger than target value. Now, well, if at least three, there is three elements in the array, then we go into this while loop. First we find out the mid of this range. Then if pre-mid bigger than target, it means we find out the element that bigger than target, but we don't know if this one is the first one. So we just narrow down the range that the red bounds narrow down is to mid, because we don't know if the mid is the first one. If smaller than target, we just left move forward, because we know the mid value is not what we want. So this mid, we can move mid +1. Now there are maybe two elements left, so we need to decide which one is what we want. If pre left larger than target, it means the left now this left index is what we want. So return left index. Else if right, if left is smaller than target and the right bigger than target, we return right. Or return -1, it means we didn't find out. So there is no element that larger than target. So we can get this index with this index is larger than the target, which the target is root. So the index the element after this index, including this index, is the root, the right subtree. Before this index is left subtree. The array pre, the target is the left, and the range is left +1 because we don't want to search the left anymore. We want to search the rest range, and right. The left subtree range is from left and index -1 because the index is the first element, which is that larger than root. So the right, we build right subtrees from pre from index and right. But we still need to consider the corner case, that there is another case like this. If, for example, if a subtree like this, if when we preorder traverse it, it will be 4 and 2. Once 4 is this subtree's root, but we can't find the first element that larger than 4, then it will return -1 to this index. In this case, it will count. It won't find because the 2 is still 2 is 4 left node. Because the index is -1, then this root left in this case -1, it will from left to -2, then return null. So in this case we need to check this corner case. If index equals to -1, but at the same time left is still smaller than right, it means this root has left node, but this root doesn't have a right node. So in this case, the search range will be from left and right. Else, it has left, it had left subtree, the index not -1. Just we can build as a normal solution from left to index -1, and we also need to consider the corner case. Otherwise, also won't build the root red subtree if index doesn't equal to -1. It means it will have a left red subtree. Then return root. Okay, this is our the code. Yes, helper function. Because the left subtree is from left +1, because left is the root node, so the left subtree must be from left +1. Okay.